Hi everyone, thank you for joining. So in this video we're going to solve another positive integer question. So we're given this equation and we're told that x and y are positive integers. Now the aim of this video is not only to solve this equality, but solve it using different methods which we can employ in more complicated situations, more challenging questions, right? So if you like to pause the video here and try it yourself first and see if you could come up with different methods of solving this question, then we could go over it together. Okay, so the first method, right, method 1, that one would use to solve integer equations is normally inequalities. So because x and y are real numbers, so we say x, y are element of not only real numbers, but they are positive integers, we know that. That means they can be ordered. So arbitrarily, we can say x is less than y without loss of generality. That means 1 over x plus, if you replace y by x, that is 2 over x. Now, since x is less than y, this will have to be greater than or equal to 1 over 3. Yeah. Or we could equally say that 2 over x is greater than or equal to 2 over 6, right? Okay, so what are the possible values? Well, x belongs to the set. Now, x cannot be 1 because if x is 1, you already have here 1 plus something which is much bigger than 1 over 3. We can't have that. X cannot be 2 because half is greater than a third. Yeah. X cannot be 3 because if this is 1 over 3, it's already equal to 1 over 3 and we're adding a positive quantity, so that doesn't work. In other words, x can only be 4, 5 or 6, as in this inequality here, right? Now let's test these values. So if x is 4, we have 1 over 4 plus 1 over y is equal to 1 over 3. That implies 1 over y is equal to 1 over 12. So that implies y is equal to 12. So that's the first solution. So y is 12, right, when x is 4. So I should write it explicitly here, x is equal to 4. And now next thing is x is equal to 5. So if x is equal to 5, we have 1 over y is equal to 1 over 3 minus 1 over 5, which is equal to 2 over 15. So that implies y is equal to 7.5, which is not an element of positive integers, so we ignore that solution. Lastly, x is equal to 6. 1 over y is equal to 1 over 3 minus 1 over 6, which is 3 over 18, which is equal to 1 over 6. So that implies y is equal to 6. Yeah. So the solutions we found are x is 4, y is 12, x is 6, and y is 6. And of course there is one more solution, exploiting the symmetry of this equation. If 4, 12 is a solution, 12, 4 is also a solution, right? Now let's solve it with another method, and that would be, let's rearrange it. 1 over x is equal to 1 over 3 minus 1 over y, which is equal to y minus 3 over 3y, implying x is equal to 3y minus y minus 3, right? And that could be written as a 3 plus 9 over y minus 3, isn't it? Because that will give you 3y minus 9 plus 9 over there, so it's the same thing. So x is equal to 3 plus 9 over y minus 3. Now we know x is a positive integer, so it's element of positive integers. That means this here must be an integer as well. But since y is also a positive integer, so the only possibilities here is that y cannot be 1, it cannot be 2, it can't be 3. So we start with 4, so y belongs to the set 4, right? It can't be 5, but it can be 6, right? And it can be 12, isn't it? So if you notice, we have y values 4, 6, 12, and if you find the corresponding x values, that you will see, we will have the same solution set as 4, 12, 6, 6, and 12, 4. Okay, so the method 3 would be simply looking at the equation and do a cross multiplication. So we have y plus x over xy is equal to 1 over 3. That implies y plus x is equal to xy over 3. So 3y plus 3x is equal to xy. So if you bring everything on one side, we have xy minus 3x minus 3y is equal to 0. Now we have 3 minus 3 there, so if we simply add 9 to both sides, we have xy minus 3x minus 3y plus 9 is equal to 9. So if you look at left hand side now, it's quite easy to factorize because we have x minus 3 and y minus 3, which is equal to 9. What are the possibilities here? Well, x and y are positive integers. So let's see, can we get 1 times 9, 9 times 1, 3 times 3, minus 3 times minus 3. Let's consider everything without thinking about it first, yeah? So minus 1 times minus 9. Okay, now, since x is a positive integer, it is impossible to get minus 9 here. And same applies to y. And again, x and y are positive integers, so you can't get minus 3 because x and y has to be 0, right? Using the first possibilities, we have x minus 3 is equal to 1, y minus 3 is equal to 9, so the solution is 4 and 12, isn't it, xy? So this is x, this is y. The second possibility is we have symmetry, so 12, 4. And the last one, if x minus 3 is 3, and y minus 3 is also 3, we have 6. X is 6, y is 6, all right? Okay, well, I hope you enjoyed it. I hope you found it interesting. And one of the purpose of this video was to explicitly show that indeed there could be one right answer, but there are so many different methods leading the same answer, right? And these methods, one can be more advantageous than the other when you're dealing with more challenging questions, right? I hope you enjoyed it. I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.